so this problem, we're like 15 minutes into it, and it's easy to forget what you were doing. But eventually we want to know what is y2. To do that, we need to know what is u. To do that, we need to know what is w. So at this point, I want to isolate w so I can move on with my problem. I'm going to need natural log properties to make all this algebra work out, just like sometimes we have to do that when we're solving separable equations. So I've got this negative integral p dx plus c that doesn't have to do with natural logs. I'll put it on one side. And then I'm going to move the natural log of y1 over with the natural log of w. That gives me natural log w plus natural log of y1 squared, because that's what we can do with numbers that multiply natural logs. And that's natural log w y1 squared, because that's what we can do with sums of natural logs. If those natural log properties don't come to you instantaneously, it's okay. I know it's been a while. You can always flag somebody down for help with it. And they almost always come up in the solving for constants part, not this part. But what we're going to get is that wy1 squared then would be, if we take each side of this equation that we've got, the far left and the far right, and put them inside an exponential. So the right side gives me my wy1 squared, and then the left side gives me that exponential that's left over. And we're always able to pull a constant out front when it's actually being added inside an exponent with that multiplication property. So we have w, the thing I wanted to find right now, is e to the minus integral p dx times a constant divided by y1 squared. I want to find u. So we need to undo the part where we substituted w in, the part where we changed the order of everything. I'm going to move to the next page, so hit pause if you're still writing. But since we took in that step that w is u prime when we introduced it, that means I can get back to u by just integrating w. And then that u is the one that I would use to find y2. That's why I care about it. So u is going to be the integral of w, or it's going to be the integral of c e to the integral of minus p dx over y1 squared dx. And then y2 was u times y1 way back when we started this problem. So that means that it's just going to be y1 times everything that I just wrote. And the general solution is going to be y1 times c1 plus c2 times the y2 I just found. And now we have finished this problem. So congratulations, you solved your first reduction of order problem. It is the hardest one you will ever have to do, and it's only going to get easier from here because we will never do the generic case again. Because there's so much that went into that problem, I do want to talk about some things that can go wrong or that you have to carefully think about. First of all, Do not memorize this formula. Memorizing this formula and plugging it in and evaluating those integrals shows me that you can do calculus, which is worth approximately 0 points in differential equations. So I know it's tempting, but enjoy the process. You only get to take differential equations once. I mean, I guess you can take it more than once. You should still make the most of the times that you take it. So please do not memorize the formula. One issue that can happen here is that you can end up introducing too many constants because you're taking about 100 different integrals. So I want to show you somewhere I could have done that. Like when I had this u I was taking, I could have added an extra constant here. And that would have kind of carried through everything I was doing. And then when I have this c here and this c2 here, I end up having too many constants because they multiply by each other. And so I'm going to show you the places where you can have too many constants. I'll write them out and sort of like the way that you cancel them out. But in general, at the end, you should just make sure I've got c times y1 plus c times whatever came out of the reduction of order problem, just two constants. But here are the examples of getting too many constants. If you have u equal to the integral c e to the integral minus p dx over y1 squared dx in, I am so mad at the tablet today, in this step right here. And you also, when you compute that integral, introduce like plus a constant k. That's going to lead you to y2 is y1 times that big old integral plus k. So that's going to lead you to the general solution. Y is c1 y1 plus c2 y1 times all that stuff. Right there. I just copied it back down. That's why I went through it kind of fast. If you're seeing any of those extra constants that aren't C1 or C2, don't worry, but this is how you get rid of it. So that plus k that you might add in your integration becomes part of C1. And the c that's inside this integral that I wrote becomes part of your C2. So this is some coefficient C2, and this is some coefficient C1. Again, you can rename your C's all the time without adding extra tildes or anything. I try to be specific that that's what I've done, but you don't have to. Just, you would turn this into one number and this into a different number. A couple warnings that I want, pause here if you're still writing. But a couple other warnings that I wanted to give you, just sort of written in one place in your notes, is combine constants. To have only two. This is a method for second order equations, so if you do it and you get more than two constants, something went wrong. It should look like y equals c1 y1 plus c2 y1 times u. Because y2 is y1 times u. and u is that thing with the funky integral inside. Something that I see go wrong is that people try to cancel out the y1s before integrating. So if you have this that you're trying to do, and let me make sure that I wasn't too sloppy about those dx's. Just at that last part, sorry, when I saw it I realized I didn't write that dx. But when you're trying to evaluate that integral, you cannot cancel out the y1 outside with the y1 inside. So it would never become this. And if you're plugging in all your functions like as you go, doing the process with a given p and a given y1, that won't occur to you. That's normally a risk with people using the formula, which reminds me, don't use the formula. I know you all are going to think it's silly that I said it like 3 times, but I'm still going to have to look at somebody using the formula in the next like few weeks of class. So please don't do it. The other thing I wanted to do was another example where we actually have functions p and y1 to work with, and it's so much easier than this one we just did. So in the next video, I'm going to go ahead and start that.